What's up, Sewing Squads? Exponential growth and decay is probably one of my favorite lessons and topics because you can apply it to like pretty much everything in life. So exponential growth, exponential decay. In my last video we talked about how the graph looks like. Growth and decay, we showed you that growth, your graph looks like this, going up. Decay, think about your graph going down. And there's horizontal asymptotes there. These are your parent functions. So in life, there are a lot of things that are decay and growth. A lot of them we talk about growth when we talk about banks, when we talk about interest. When we're gaining money at a bank at a certain percent, we're actually making money because you might start at $10 and then you might make 10%. So the following year, you make $1 and you make $11. So now we're at $11. So we made an increase of $1. But what happens? You don't take 10% of the $10 again because we're leaving that money in there. So we're actually making the money from this $11 now. So now we take 10% here, which is 1.1. So now we have $12.1. So we made 10 cents more from our $1.10 more from previously. So why? Because we're not starting at our initial, we're starting from the end of the year, which now we have $1 in there. So slowly more money is going to be there. So obviously initially we start slowly, and as more money builds up, we're going to start doubling and tripling. It's going to start growing at a faster rate. So the longer you put your money in there, the more money you're going to have. It's going to eventually grow at a faster rate. We want to get to here. Same thing with decay. Cars depreciate in value. You might buy a brand new car, take it out of the lot, and all of a sudden now you drive it around, you put miles on it, it's going to depreciate. You're not going to be able to sell it for the price that you bought it for. Electronics. Think of like iPhones. You buy a $1,000 iPhone. Next year when the new iPhone comes out, you can't sell that phone for $1,000. No one is going to buy that phone for $1,000 when the newer model came out for $1,000. So it starts depreciating, and it's used, it's worn out, there's scratches, so then we start losing value on there. So that $1,000 phone next year might only be worth $900, and then $700, and then $650, and then slowly, it'll never get to zero. People will still buy iPhones for like, $10, $20, $50, depending on what iPhone you have. So you always make money off of it. So this is an example of decay. So with growth and decay, there is a formula that you want to introduce. It's very similar to the one that we use with growth and decay. We have y equals p. P is your principal, P is your starting. How much money are we putting in the bank? How much money is the car worth? 1 plus r to the t. All right, so P represents your principal. How much money is in there? It's your initial. I like to say your initial. Y is your final value. How much is it worth after t years? So t is years, time. And then R is your rate, your interest rate but you have to write it as a decimal. So if it's 10%, make sure you use 0.1. So you can think of like clothes. When you think of clothes, you guys can calculate this in your head. 10%, if it's 10% off of $100, how much are you paying? You're paying $90 because you saved $10. So essentially, instead of this formula for decay, you're actually using 1 minus r. T is 1 in that case, in that scenario, but P times 1 minus 10%, let's say P was $100, right? We bought something that was $100. So it's 100 times 0.9. Well, what is 100 times 0.9? It's 90. So you're paying $90 for that clothes because you saved 10%. So be careful because kids get confused, because if I give you this equation here and I ask you what is the rate, a lot of kids say it's 90%. That is not true. We have to use this formula to find R. So we have to say it's 1 minus 0.9. So what is R? 1 minus 0.1. So 0.1 is what we want to get. It's 10%. Right? So it's going to be 1 minus r here. So it's 10% there. So be careful there. It's not that value. We have to subtract 1 minus that to get this guy. So we want the 10%. Same thing here. If I gave you something like 1.25, it's not 125%, it's 1 plus r. R is going to be this 0.25, which is 25%. All right, so we're going to try 3 examples, our beginner, intermediate, advanced level, to try and practice exponential growth and decay. All right, first example, find r. What's my rate? So if you have these 2 examples, so I give 2,001.25, and then I give you 1,000.85. What's my R value in both these cases? What's the rate that we're using? So I'm going to give about 30 seconds to a minute. Try your best. It's okay if you get it wrong. Go. Okay, what is my R? So here, remember, it's 1 plus R. So if you want to set up an equation, 1 plus R equals 1.25 and solve for R, that's okay. So R is what? 0.25, so it's 25%. So the 25% increase, we're increasing something by 25%. Here, what is it? It's a decay because it's less than 1, so it's 1 minus R equals 0.85. So if you solve for R, it's 0.15, which is 15% decrease. So check your answers. This is an increase. So check your answers to make sure you guys get this correct. Let's move on to our intermediate problem. All right, intermediate problem. Let's say your parents gives you $100. Your parents gives you $100. So you have $100 and you put it in the bank because you want to make some money at 10%. And I want to figure out, well, I'm in college or I'm in high school for 4 years or in college for 4 years. I want to see how much money I'll have if I invest in this bank at 10%. So your college is 4 years, or high school is 4 years. All right, so I want you to set up the equation. We're not going to solve it, but I want you to at least set it up to see what we have. So I'm going to give you about 30 seconds to a minute. Go. All right, let's set this up. So you have your future equal your present. We're making money. So we have that. So what do we have? We're trying to find this guy. We're trying to figure out in 4 years how much do I have. That's my unknown. What do you start off with? You start off with 100. My interest rate is 10%. Remember, decimal time 4 years. So your answer should be 1.1 to the 4th power. So that will give you how much money you'll have if you deposit into a bank that gives you 10%. All right. So then $100 is what you start off with. 1.1 is your increase of 10%, and then we're going to try to figure that out in 4 years. Check your answers, make sure you did that correctly. Let's get ready for our advanced problem. Our last problem, compound interest. Let's talk about this. The formula is similar. We're compounding it n times per year. So the only thing, it's the same formula as 1 plus 1 minus r, but now we have this divide by n to the n power. The n just represents the number of times compounded per year. So if I talk about, if it's compounded 4 times per year, then n is 4. That means 4 times every quarter you're going to have one. Or if it's 3 times per year, semi-annually, twice per year, monthly, 12 would be n. Weekly, daily, hourly, all those things, that's your n value. So make sure you plug that in. So if it's the same concept, if you have $100, you start off with $100 at 10%, and they'll tell you what is compounded. So they'll say it's 10% compounded monthly. So that means it's going to happen how many times per year? 12. That's your hint. And you want to figure out in 10 years how much money will you have if it's compounded monthly at 10%. You have $100. So just try your best. Here's your formula. Just try your best, and we'll talk about this afterwards. Go. All right, let's take a look. So you have $100. You set up the same way. R is what? 10%, so 0.1. Compounded monthly, so 12. 12 times 10. The reason why it's 12 times 10, the reason why it's NT, is think about it. You want 10 years worth of compounded. It's compounding 12 times per year. So how many times do you have in 10 years? You have 12 times 10, which is 120 times. It will be compounded for 10 years. So this is your equation. All you just plug it in. You get your future value. And that's something you gotta look at. Look at your the intermediate. Look at this problem. See what happens if you compounded more. The more you compound, what happens? Does it change your answer here? Does it give you more money? Does it give you more interest at the end, or is it very similar? So that concludes our lesson with exponential growth and decay. Hopefully these videos helped you. Please subscribe to my video, turn on your notifications, and let's get ready for some more videos.